Consumer behavior is one of the key topics in economics, where we're going to look at consumer preferences, the utility functions in different scales, marginal rate of substitution, the budget constraints, and the consumer equilibrium. So we are going to look at your behavior as individuals, as consumers in that capacity, and how they affect your incentives on your decisions. We're also going to look at consumer in deciding on a basket of two goods to consume limited by a budget. We are also essentially going to look at how the consumer is a decision maker and how to maximize utility. Utility simply refers to the power or property of a commodity to satisfy human needs. So in dealing with utility, you're looking at satisfaction. And there are two approaches we're going to look in terms of satisfaction: the cardinal utility theory and the ordinal utility theory. Now, the cardinal utility theory basically looks at satisfaction or utility as being measurable. It assumes that price one pays should be equal to the satisfaction they get or derive from consuming a certain amount of goods being bought, and therefore the total utility that emanates from the units.
I can't get you. Is it my network?
Can the others get me?
Yes, we can hear you.
Maybe it's your network, yeah? Am I clear now? All right, so kindly adjust your parameters there. So total utility, we are told from one unit of the service is the sum of the incremental satisfaction that are obtained. So when you're talking about total utility, it works on the law of diminishing returns. So if we have a function like this here, so one additional unit adds the total utility. So this is what is happening here, adding two. So what we're going to have here is what we call the total utility. So this is U1, U2. So when you're adding these utilities, we call them marginal utility. Marginal is simply the addition of satisfaction, which contributes to the total utility when we are consuming two goods, X and Y. Now, in utility or satisfaction, we've talked about two models. We also have what we call the ordinal utility theory, which assumes that utility cannot be measured. So it uses what are called indifference curves to explain consumer behavior. And these indifference curves show various combinations of two products which give us equal amount of satisfaction. So if we're dealing with the consumer, we're looking at a consumer having tastes or preferences that will determine the amount they will choose to purchase. So we're going to look at a downsloping curve, which we call an indifference curve. It looks like this. And this indifference curve has the following properties. Number one.
Sorry, to cut you short. During the lecture, he had indicated that he will focus on one and not the other. I don't know if there's anyone who's here who remembers to say that and which one he focused on.
Yeah, it's
I don't know.
I think he
focused on
specifically.
Okay, I know.
Yeah, but then I think he didn't
Right.
explain why. I didn't get the exactly why he did, but it wasn't that much explanation.
He just indicated that for the sake of this class, he wouldn't focus on one of them, which should have been the second one you explained, I think.
All right, okay. I'll explain both of them needlessly, but the one with calculation is the one that I'll dominate on because that's the calculations I want to look at.
Right.
All right, so So the properties of indifference curves are just 6. Number one, you need to understand that the indifference curve that is nearer the origin has the lowest level of satisfaction. So this indifference curve 1 has the lowest satisfaction. So the indifference curve 2 is higher than 1. The indifference curve 3 is the highest of them all. So as you go up to the right, you offer higher indifference, higher utility. Number 2, the indifference curve has a negative slope because it is downsloping. So number 3, the indifference curve do not touch the axis. So this was not well drawn. So it's supposed to actually look like this. So the indifference curves are, they don't touch the axis. And the indifference curve at point B is the most optimal. A is underutilizing resources. B is the most optimal, which is tangent to the budget line. C is above the budget line. It's unattainable. Budget line is simply our center of discussion today. So the point at which the budget line kisses the indifference curve is what we call the marginal rate of substitution. So marginal rate of substitution is where the optimum bundle occurs. So marginal rate of substitution. So this is good Y and good X. So we want to calculate the point at which good Y and good X are maximized. All right. So the other properties are that it is convex, not concave. So this was one issue where having discussion was people made a mistake. And also you need to understand that along the indifference curve, total utility is constant, but the marginal rate of substitution changes. So the satisfaction that is attained at this point is the same as satisfaction that is attained at this point. But the movement from this point to this point brings about what we call marginal rate of substitution or opportunity cost. So if you're moving, for instance, from 4 to 3, you're going to gain maybe from 1 unit to 5 units. So this loss of 1 unit in good Y will make you gain 4 units in good X. So plus 4 at the expense of 1 minus 1. So this is what we call opportunity cost. This is what we call opportunity cost. Now, marginal rate of substitution simply is defined as the quantity of one product which the consumer is willing to sacrifice in order to buy or attain another unit, but maintaining the same indifference curve. So that is what we call the marginal rate of substitution. So maybe the satisfaction here is 10 U-tiles, this is 20 U-tiles, and this is, even if we're going to move from this unit X to Y, the utility along this difference curve is still 10 U-tiles. But the marginal rate of substitution from X to Y changes because you are losing 1 unit of Y and gaining 4 units of X. So this opportunity cost is what we call the marginal rate of substitution. Now, we have 10 formulas to know. So we have what we call the budget line. Our income is equal to price of X times X, price of Y times Y, where I is the budget of the income, PX is the price of X. So in the event that you have 100 kwacha to spend on 2 goods, good X maybe is 10 kwacha, good Y is 20 kwacha. What is our budget line? 100 is equal to 10X plus 20Y. So this is our budget line. How do we draw this budget line? The letters on one side. So here there's a 10. 10 into 100 It is 10, so X will cut at 10. And 20, we divide it into 100. 20 to 100, what we get? We get a 5. So if we're going to draw the budget line under Y and under X, this is what will happen. Under Y and under X. So to cut the Y-axis at what point? At 5. And to cut the X-axis at what point? At 10. So this is the budget line. Let's try again. Suppose you have a budget of 200 and good X is costing 5 kwacha and good Y is costing 20 kwacha. Can you come up with a budget line? Who wants to try? $200 is equal to what?
5x
Plus
plus 20y.
20y. Then the intercepts, where will it cut the x-axis? X will be 200 divided by what? By 5. And y will be 200 divided by what?
20.
20. So what do we have here? 40. And what do we have here? 10. So here we have y and here we have x. So where will it cut the y? At 10. Where will it cut the x? At 40. Is that clear? So this is our budget line. 200 is equal to 5x plus 20y. Now suppose this consumer wanted to consume 8 units of y. How many units of x will they consume? We can substitute it in here. So where there is y, we're going to put 8. Right? So what are we going to have here? We're going to have 200 is equal to what? 5x plus 160. When we apply to 20 times 8 is 160. So when this one goes decided to subtract, what are we going to have? 200 minus 160 is equal to what? 5x. And then what are we going to have on this side? 40 over 5x. So meaning our x therefore will be what? X will be 8. Is it? What is 5 into 40? What do we have?
8.
8. So x will be 8. All right. So when we put 8 there, is it going to give us 200? 8 times 5 is 40. 8 times 20 is 160. When you add 160 plus 40, are we going to get 200? Yes. All right. So we can also calculate the margin rate of substitution.
Mr. Collins, sorry to take you back. Where are we getting that 8? The one that we marked on the graph?
This one you're given.
The 8 is given? Where is it given, Mr. Collins?
I just mentioned because I made this question.
Oh, all right.
So now let's go to the overnight test, which came last semester. So we're told that a consumer in equilibrium at point A, in this figure here, the price of good X is 5 kwacha. What is the price of good Y? So equilibrium is at point A. All right. So at point A, that's where our equilibrium is. So let's look at this carefully. Here there's what number? This is 30. Here what number is there? 20. All right. We are being asked to calculate the price of good Y, 5 marks. So from what I'm just from explaining, if this is 30, no, this is 20 as well. It's 20, 20. If this is 20 and this is 20, all right, then at equilibrium, we are given what? Point A. This figure here is 10. What is the price of good Y? If the price of good X is 5 kwacha. So you need to think from the lines that I have just indicated. So if it's cutting here at what? 20, and it's cutting at 20. And this is Y, this is X. Can somebody give me the budget line? Budget line is what? I is got what? Price of X times X plus price of Y times Y. So we don't know what the budget is specifically, but we know that the price of X has been given as what? 5. All right. And the price of Y, we don't know, is what we are looking for. Price of Y times Y. All right. So it is cutting the X at what? At 20. So when you divide 5 into this number that we don't know, it is going to cut at 20. So for us to know this number, just multiply 5 times 20. So meaning this number must be 100. All right. So we also know that it's cutting the Y-axis at 20 also. So for the number that is here that we don't know, how do we get it? We just simply divide 20 into 100. It is giving us what? A 5. So meaning the price of Y is also 5. I repeat, if you are given the price of X as 10 kwacha, for instance, and you are given just a graph to see, this graph here, maybe they've given you, this is 50 kwacha, and maybe this here they've given you is 30 kwacha. And then told you that the price of what is at equilibrium at point A, and the price of X is 5 kwacha, 10 kwacha. What is the price of Y? So use the same equation here. I is equal to what? Price of X times X, price of Y times Y. So let's start substituting here. So the price of X has been given as 10. So 10 plus the price of Y we don't know against Y. Price of X is 10X. So from this graph here, it is cutting the X-axis at what figure? At 30. So you put the 30 there. So to get the total budget here, we multiply 10 times 30, meaning our budget should have been 300. And we know that it is cutting the Y-axis at 50 already. This is leakage, but we don't know the price of Y. So for us to know the price which will come here, we'll simply divide 50 into 300. So this one will give us 6. So meaning the price of Y is 6 kwacha. This question is better. The previous one that we are looking at is very easy because you can be able to tell if the price where it's cutting, this is 2020, it means the same price even with that calculation. If the price of good X is 5 kwacha, the price of good Y should also be 5 kwacha at equilibrium. So let me go through it again. So this line here, it is specific to say at point A, we're in equilibrium. So we're looking at this line here. The price of good X is 5 kwacha. So good X is 5 kwacha. Now what is the price of good Y? So if good X is 5 kwacha, what is the price of good Y? So you go to calculate. So we know that 5x, which is 5 kwacha, should be equal to dash Y. We do not know. But the X is cutting at what figure here? The X is cutting at 20. So you put your 20 there. So meaning the budget is 5 times 20, we're getting 100. Then Y is also cutting at what? 20 here, the same figure 20. So even if we're going to divide 20 into 100, it's going to be 5 kwacha. If at Y here, there was a figure like 50. So 50 into 100 would have gotten a 2 kwacha. So meaning the price of good Y would have been 2 kwacha. Then what is the consumer income? We've already calculated it. This is the budget, which is 100. Consumer income is 100. Then at point A, we are told how many units of X must, how many units of good X must a consumer purchase. So what we've calculated is just the price. So at point A, we know that point A, we have 10 units of good Y. So to find the units of good X, it's at equilibrium. These units should also be 10 units, ideally. But we'll prove it. So if there are how many units at good A have been consumed of good A, it is 10 units. So we substitute this equation here. So we've come up with a full equation, which is 100 is equal to 5x plus 5y. But where is the 10 coming from? The 10 is coming from the equation itself. They'll just give you an idea to say at point A. So what is at point A is telling us here to say point A has what? Point A has how many units? Has 10 units of Y. So they're asking us to find how many units of X. So we just go here and substitute Y. This is 10. So we're going to have 100 is equal to 5x times plus 50. So we're going to have 100 minus 50 is equal to 5x. So we divide both sides. This is 50, it's equal to 5x. We divide both sides by 5. So over 5 there and over 5 there. So meaning our x is equal to 10 units as well. This question was too easy. As an overnight test. Then now we are told that suppose the budget changes, the consumer achieves a new equilibrium at point B. So what change in the economic, what change in the economic environment led to the new equilibrium? Then also, is the consumer better off or worse off? Now, before we analyze this question here, I need you to understand that a budget line looks like this. So if we have Y here and X there, the only reason that will cause us to tilt inwards here is when good Y becomes what? Expensive. So if we're buying 10 units of Y, now we're going to buy 5 units, it becomes expensive. So this is called a tilt. Whenever we're tilting inwards, it means good Y has become expensive. If we're tilting outwards, it means good what? Y has become cheap. So meaning maybe we're buying from 10 units, maybe we're buying 20 units. So this means we are improving in our livelihood. Similarly, the same can happen with good X. If this was a normal, we have 10, 10 there. We can only tilt inwards on X if X becomes what? Expensive. So meaning if we're buying 10, maybe we're buying 6 units of good X. So this is called a tilt. It's called a tilt. We can also tilt outward on X. This means that we are now able to afford better. So we are affording more from 10 units to 50 units of X, maybe because there's a promotion in ShopRite. But there's also what we call a shift. If our budget was like this and our income has increased, so we're going to shift evenly outwards. So meaning maybe we're consuming how many units of X? 10, and now we're going to 20. How many units of Y? 10, and now we're going to 20. This is called a shift. We can also shift inward if the budget constricts. It is now limited. So we're buying 5 bags of mini meal, 10 bags of mini meal. Now maybe we're buying 5 bags and 5 bags there. This is called a tilt. So from this here, our equilibrium, can somebody tell me what is happening? From point A, the equilibrium is now at this point there. Are we having, what economic change is happening in the environment? If you're listening to me, somebody can explain what was happening here. Anyone? So evidently, it seems our units of Y are now increasing from 20 to 40. So it seems the price that we were actually buying good X, which was at 5, should have been reduced to half for us to double our consumption on Y. So this shows that there's an improvement. Good Y has become cheap, so it's tilting outwards. So this is causing our ability to purchase more. I think this is what I was just explaining. All right. Any questions? Are we together? Are we moving together?
Mr. Collins, kindly scroll upwards and look at the question.
All right. So this is basically using the budget. So utility is very important. We can also illustrate this. Suppose the consumer's income was 40 kwacha between good X and Y, and good X is 2 kwacha, good Y is 1 kwacha. Let's prepare a budget line. So How do we draw a budget line here? A budget line becomes what? 40 is equal to 2x plus what? 1y. Then how do we sketch this? We to cut the x2 into 40. What do we get? 20. 1 into 40, what do we get? 40. So we can draw the budget line here. It will cut our x at 20 and our y at 40. So this is what I just illustrated here. Okay. It will cut our y at 40 and our x at 20. So this is what we call the budget line. Now, to find the slope of the budget line, it is simply given by the price of good x over the price of y. This is also the same as the marginal rate of substitution, x for y. It's given by the same formula. So what was the price of good x? It was 2, and the price of good y was 1. So our slope here will be given as 2. So this is how we find the slope. So we now delve into, this is what I was just explaining, a question where we are told that Fanta, of course, Fanta costs 5 kwacha and Coca-Cola costs 6 kwacha, and the budget was 30 kwacha. Write down the budget line. So you can make a budget line with the letter that you have. 30 is equal to 5F plus 6 Coke C. So to cut 5 into 30, 6. 6 into 30 is 5. So you can call this your Fanta and this your Coke. So the budget line will cut Fanta at 6 and will cut Coke at 5. So they'll ask you now, what is the marginal rate of substitution? Fanta for Coke. So it is the price of Fanta over the price of what? Coke. So price of Fanta was what? 5 kwacha. Price of Coke was what? 6 kwacha. So this is what we call the marginal rate of substitution. Fanta for Coke. But if they say marginal rate of substitution, Coke for Fanta, you start with the first thing that was mentioned. Price of what? Coke over price of what? Fanta. The price of Coke in this case is what? 6. Price of Fanta is what? 5. So this is what we call the marginal rate of substitution. Any questions at this point?
It's clear.
It's clear? All right. Any questions? Any other questions? Okay, so we now go to the utility function. The utility is given in terms of x and y. So du over the x is called the marginal utility of x. Du over dy is called the marginal utility of y. So to maximize utility, the price of x into the marginal utility of x must be equal to the price of y into the marginal utility of y. So this is what we call the optimum bundle. This is what we call the optimum bundle. So I was trying to labor to explain to you how we differentiate implicitly. So if we have 5y x6, we differentiate this, mu x is equal to du over dy, and the x, sorry. So multiply 6 times 5, we get 30. And subtract 1 from the 6, we get 5. If we had 6x4, 6y4, to get the marginal utility of y, it is du over dy. This is 24, y to the power what? 3, because you multiply 4 times 6 is 24, and subtract 1 from there. But when these are combined, 6x5, y3, you can differentiate them implicitly. Mux, you leave the y to the power 3 as it is, then differentiate. 6x5 becomes 30 what? x4. So we differentiate this one the normal way. 5 times 3, 5 times 6 is 30, subtract 1 from the power. It becomes a power what? The power less by 1. Then similarly, mu y. Our dummy in this case will be x to the power 5. Leave it as it is. You cut it and paste it without altering it. You put it here. So meaning what we're going to remain here is 6y3. So differentiate 6y3, but maintain the order in alphabetical order. So this becomes 18y what? 18y2. That is how we differentiate. So if we have u is equal to 10x2 and y. So marginal utility of x, the shortcut can write ux. Our dummy is y. And we're going to differentiate 10x2, which is simply 20x. We want to differentiate with respect to y. Our dummy in this case, that's where people have a problem now. X squared. So what is going to remain here are just these two, 10y. 10y differentiated is simply 10. The y falls out. I think I labored hard this afternoon to explain such issues. Even if I didn't, I'm sure you're getting it right now. If you have marginal utility 2x squared or x half, y half. If you want to differentiate with respect to what? To x. Our dummy here is y half. Then we're going to differentiate 2x half. So half times 2 is 1. We never write 1. Then half minus 1, it is negative half. So the negative will be on the x. Same if we're going to differentiate with respect to y. Our dummy here is x half. So we're going to remain with 2y half. Half times 2 is 1. We never write 1. Then from this y half, we're going to subtract half minus 1 is negative what? Negative half. All right. Now, I'm trying to take us to what we call the Lagranian multiplier, which makes use of what? Differentiating the utility function with the lambda function, and here we put the budget constraint. Pxx, pyy. Now, this Lagranian function is summarized by this easy function, which we call the optimum bundle. So let me show you how this is done. So we are told that we have a utility function. In this case, we have a utility function. Let me go to our our module. This came in the exam. So we're given a utility function 10x2y, and the price of x is 10, price of y is 5, and the income is 150. All right, so utility is what? 10x2y. Price of x is what? 10. Price of y is what? 5. And the income. They use B, they use Y, so this is capital Y, 150. So can somebody help me? What is the budget line? 150 is got what? 10x plus what?
5y.
5y. And how are we going to sketch this? Intercepts 10 in 150, 15, 5 in 150, 30. All right, so how does the budget line look like? Y is here, x is there. It will cut the intercepts here. Y at what? 30. X at what? 15. Then we want to calculate the point at which utility is maximized, the optimum bundle here. So this is our utility function, 10x2y. So we want to find how many of y and x will maximize this equation. So we've done only first part of our work. I love economics. All right. So with this function 10x2 and y, we're going to find the marginal utility of x. Can somebody remember? How do we differentiate this? What is our dummy?
Y.
Y. Then what do we differentiate? 10x2, which becomes what?
20x.
20x. Then we go to differentiating marginal utility of what? Y. What is our dummy here?
x2.
X2, good. And what are we differentiating?
10y.
Which becomes what?
10.
That's 10, excellent. And how do we optimize the bundle? MUX should be divided by the price of what? X. This should be equal to MUY divided by the price of Y. Then we now substitute. So 20 XY, 10 X squared. And what was the price of good X? X was what? 10 kwacha, Y was 5 kwacha. So what Y hapa, 10 kwacha and 5 kwacha there. All right. So you could choose to cross multiply if you want. So here 10 times 10 is 100 what? X squared. 20 times that, we're going to have 100 XY. Then we can divide both sides by 100x. 100x, 100x. What are we going to remain with? X is equal to Y. Do you agree with me?
Sorry, Mr. Collins, how are you finding the 100?
I'm lost on that one.
Well,
Next is equal to y most.
Martha, explain to them where we get the 100.
So the 100 is coming from just the formula is MUX over PX, and we found these, so we're just plugging them in from what we had found. So we found 20xy, and then our PX from the question was 10, and then our MUY was 10x2, and our py from the question was 5. So we cross multiply. So 20xy times 5 is going to give us 100xy, and our 10x2 times 10 is giving us 100x2. And then we divide by 100x because that's the common like common something. So when we cancel them out, we remain with x on this side and we remain with y on the other side. So x is equals to y, I think.
Excellent. Is that clear?
Yes.
All right. So after we find our x is equal to y, we go back to our budget line, which was as follows. And x plus 5y was equal to 150. Since x is equal to y, we can choose any of them to substitute as long as we have one letter. So I have x, so where there's y, I'll put x. So this will be 10x plus 5x is equal to 150. Then when we add these two, we're going to get 15x is equal to 150. Then to find the value of x means we found the value of y as well. So we divide both sides by 15. And so this divided, this divided, so our x is equal to 10. So if x is equal to 10, x is equal to y. So we have found the values of x and y, which is equal
Mr.
to
Collins, on the second line, how is it becoming 5x?
because y is equal to x. So I could choose to put whether there's
Okay.
x is y is either of them. All right, is that clear? So now I'm able to tell to say maximize my utility, x must be 10 and y must be 10. And so I rest my case. Let me verify what he got in here. All right, did this and that and that. Use the Lagranian multiplier. He went down there. He used the subjective formulas and he found the same values. All right.
So Mr. Collins, using the Lagrangian multiplier and the other method you've used, you arrive at the same answer.
Yes, absolutely. You arrive at the same answer. Next question is, am I going to be penalized if I use this method and not the other?
That was my next question.
No, you don't be penalized. It's the same. This is just a simplified Lagrangian approach. But I'll teach the Lagrangian as well. I don't mind.
I think okay. I think you should share this the workings you've just done. I think I came to find it so easy working around the formula you are just from doing, unlike this one.
Oh, yeah. Okay, so I'm teaching the toughest topic in this course, like a story. So Lagrangian multiplier, Lagrange, you have the utility function. I can also simplify, I think, this jargon here. Okay, so in this case, we have this Lagrangian multiplier. Our utility function is 10x paired y plus the lambda. The function for the budget to remember was 150 minus what? 10x minus what? 5y. So we can spread our function as follows. So this is 150 lambda, and this is 10x lambda, and this is 5y lambda. We've just expanded this. So we're going to differentiate with respect to x, differentiate with respect to y, differentiate with respect to lambda. Let's see whether we're going to get the same formula, the same answers. So here where there's x, differentiate this, our dummy is y. So we're going to have 20x and y. Here there's no x, so this is 0. Here there's no x, this is 0. Here there's an x, so this will remain as what? 10 lambda. Because x is the power 1. So when we equate this to 0, we're going to have the lambda come this side. So 20 xy is equal to 10 lambda. So meaning the lambda, in this case, for x, lambda for x will simply be divided by 10 both sides. We're going to have 2xy. Then we go to differentiating with respect to y. Our dummy is what? x2. So we differentiate our y here, is simply going to have what? Differentiate with respect to y. So we're simply going to remain with 10x2. Then here there's no y, it's out. Here there's no y, it's 0. Then here we're going to have minus what? 5 lambda. When you get this one to 0, we're going to have 10x squared is equal to 5 lambda. And divide by 5 both sides. The lambda for y is going to be equal to 2x squared. So we have lambda for x and lambda for y. So to equate these two lambdas, of course, here when you differentiate with respect to lambda, we're simply going to have 150 minus 10x minus 5y. When you equate these ones to 0, we're simply going to have the budget line 150 is equal to 10x plus 5y. So let's equate these two lambdas. So the lambda for x is 2xy and the lambda for y is x squared. So lambda x should be equal to lambda y. So what was our lambda x? 2xy. 2xy, and the lambda for y was what? 2x squared. 2x squared. We divide both sides by the common feature there. We have 2x here and also 2x there. So here we're going to have y is equal to x. The same thing we did. Since y is equal to x, we go back to the third partial fraction, which is the budget line. Where there's x, we put y. All right. So 150 is equal to 10x plus 5y. So since x is equal to y, I can put a y there if I want. So this will be 10y plus 5y. So this is equal to 150 is equal to 15y. So here we're going to have our y is equal to 10. So I mean, if x is equal to y, so these are the same. So you get your 25 marks, even for using Lagrangian function. Thank you so much for your time. I will end here for tonight.
Mr. Collins, let me just get the screenshot for the other one, the other workings.
All right, the screenshot for the other working, but I'm going to send the video either way. So is it this that you're looking for?
Yes.
All right, you can get the screenshot.
Is this where is this where you set it from? I want to see where you set it from.
From here.
Okay.
And here.
Okay. Thank you so much.
And finally here.
Mr. Collins, Send the video.
I'll send the video. So
Okay.
this question came in the exam, and I have sent the exam question on the group as well with the solutions, so spend time to go through it. Thank you so much.